In order to graph three-dimensionally, we need to take a 3D space and convert it to a two-dimensional space like our piece of paper. To do that, we're going to create an optical illusion. To create that optical illusion, we're going to use isometric paper. To start our 3D graph, we first need to pick an origin. So about in the middle of your paper, pick a point to be your origin. It doesn't have to be the exact middle, just pick a point that looks like it's about in the middle. And from that point, we're going to move in all the directions, three-dimensionally. So the first direction we can move from this origin is up and down. So we're going to connect to create our axis up and down. Moving back to the origin, the other direction that we can move isometrically is diagonally to the left and down, and diagonally to the right and up. So we're going to connect those points, moving diagonally down and to the left and up and to the right. And the third direction that we can move from the origin is down and to the right and up and to the left. So we're going to connect the points down and to the right and up and to the left. This optical illusion creates our three-dimensional space. The next thing we need to do is number our three-dimensional space, number our axes. So the vertical axis, I'm going to call the z-axis. And if I start at the origin and I go up, that's going to be positive in the z direction. And if I go down from the origin, that's going to be negative. My other two axes, if I move down and to the left and up and to the right, I'm going to call that the x-axis. And if I move down and to the left, I'm going to make those positive. And if I move up and to the right, I'm going to make those positive. Excuse me, negative. And my third axis, I'm going to call my y-axis. If I move down and to the right, that's going to be positive. And if I move up and to the left, I'm going to make that negative. So think of this graph this way, and if you can trick your eyes into seeing it as an optical illusion, it'll make more sense. Think of these two axes coming out towards you, and these two axes going away from you. Up would be positive, and down is negative. If you can see this as the optical illusion, these two coming towards you and these two going away, it'll make these points a lot easier to see three-dimensionally. If I want to plot the point 2, 4, 3, I have an ordered triple, x, y, and z. And just like an ordered pair, these numbers tell me in which direction I need to move. So I'm going to start at the origin, and in the x direction, I'm going to move 2, which means I'm going to go down and to the left 2. Notice that I'm tracing out my path as I go. Now from that point, I need to move 4 in the y direction. So I need to move 4 in the y direction. So I'm going to move down and to the right 4. So now I've moved 2 in the x, 4 in the y, and now I need to move 3 in the z. Now I'm not going to go back to the origin and move up 3. I'm going to move up 3 from this point right here. So I'm going to go 1, 2, 3. So to get to this point, I've come forward to the left, forward to the right, and then up. If you can see this as the optical illusion, this point is closer to you than the origin, this 3D graph makes sense. Now I'm going to label that ordered pair, or that ordered triple, 2, 4, 3. And the reason I want to do that is this point can actually be 8 different points. I can get to this dot 8 different ways. I could have gone back 1 and to the right 1. Or I could have gone down and to the right and then up. There's multiple ways to get to this point, so I want to label that ordered triple. If I wanted to plot the point, -4, -3, -2, again, I'm going to start at the origin, and I'm going to go 4 in the x direction positively. Notice again I'm tracing out my points as I go. From that point I need to go -3 in the y direction. Well, the y-axis goes this way, so if I want to go -3, I need to go back and to the left 3. And then from that point I need to go -2 in the z direction. So from here I'm going to go down 2. So this point right here is 4, -3, -2. Again, I want to label that ordered triple, and to get there I came towards and then away and then down. Let's say I want to plot the point -3, 0, 6. I'm going to start again at the origin, but this time I'm going to move -3 in the x direction. From there, I'm going to move 0 in the y direction, which means this way I'm going to move no spaces. And then in the z direction, I'm going to move 6. I'm going to go up 6. So this point right here is the ordered pair, or the ordered triple, -3, 0, 6. And if you can see this as the point going away and then up, you can see this graph three-dimensionally.